So in today's lesson, we are going to take a slightly different look at lines. So far, we've been looking at coordinates and kind of medians and finding equations of lines. Today, we're going to focus in and we're going to look at a slightly different perspective on gradients. So if we've got some line, and I'm marking some points, but just to help us think this through, then the gradient of that line, remember, is a measure of how much up and how much along we do. So the gradient is up over along, and we've got this other formula, y2 minus y1 over x2 minus x1. y2 minus y1 is just telling us how much up we've gone, x2 minus x1 is just telling us how far along we've gone. So we've got this formula. Now, slightly different perspective on that. I'm going to mark this angle. I'm going to mark it the very traditional art for angles, which is theta, which is a circle with just a line across it. Don't worry too much about the symbol, but it's called theta. So if I say theta, that's that symbol there. That's what I mean. As soon as I put an angle on this diagram, I start thinking about, well, this is the opposite to that angle. And this side here is adjacent to that angle. And then I'm thinking, oh, SOHCAHTOA. Well, I've got opposites and adjacents, so I'm talking about TOA. So I see that this is not just up over along, this is opposite over adjacent, but that's tan of that angle theta. Now, there are a few important things we're going to need to just pay attention to if we're going to make this all work. If this is going to equal the gradient, and we're going to get like positive gradients being positive amounts when we do tan theta, it's important that we use the angle from the horizontal. So it's important that this is horizontal, and it's important that we do it from the horizontal going to the right. So if I give you this angle here and start doing tan of this angle, we'll get the wrong type of gradient. So if I do tan of this angle, this would be a negative gradient, and that's quite clearly not the case. So always check, always do a little common sense check. When I work out from an angle, tan of an angle, and I try and work out a gradient, do a common sense check. Does that gradient I get out make sense? Is it positive like I'd expect it to? Is it negative like I'd expect it to be? So always check against what you get. Now we're going to do two examples of this skill in action, going each way, and see what it gives us. So I'm actually going to start with, I've labelled these the wrong way around, but it doesn't really matter. So we're actually going to start with example 2 and then do example 1. So here I've got a couple of diagrams, and in each one I'm being asked to find the gradient of the line. Now here we have an angle of 30 degrees between a line to the right, horizontal line to the right, and our line that we're interested in. So our gradient is going to be tan of 30 degrees. Put tan of 30 degrees into your calculator, and you will get the answer that we're looking for. Now, unlike most gradients, which have been fractions, often now our gradient is going to be some horrible decimal thing. So 0.577 is what your calculator will turn out when you put in tan 30. Now, next one that we're going to do is we're going to move across to this diagram. Our gradient is tan of the angle, but we need to be careful here. Our angle is between a line to the left and our line. We want it between that and the line to the right. So the first thing we need to do is use angles on a line. That's 135 degrees. So it's tan of 135. Work out what tan of 135 is. On the calculator, it'll give you -1. Sorry, that's gone really fuzzy because it's off the side. Tan of 135 is -1. That is our answer. This line has a gradient of -1. That makes sense. It's going down from left to right. If I'd done tan of 45, it would give you the answer 1, and you can quite clearly see that it does not have a positive gradient. So do always a little common sense check when you work out gradient. Same thing here. We want the gradient of this line, but we've got the angle on this side of the line, not the one over here. So the first thing we want to do is 180 take away 160 and get 20 degrees. we then want our gradient is tan of 20. Tan of 20, again, we're going to get a decimal number. So we're just popping this into the calculator. We get 0.364 to 3 significant figures. And so we've got our gradient. So that gives us a process by which we can now work out gradients given the angle. The other direction is exactly the same kind of process. So up here, we're given a line equation, and we've been asked to find the angle between the line and the x-axis, and we're asked to find the acute angle. So we'll have to talk about that in a minute when we get a wee bit further down the line. First thing we need to do is we need to reorganize this into the y equals mx plus c form. So we have 4y equals 2x plus 7 by adding 2x to both sides. Y equals, now we're dividing 3 by 4, 2 divided by 4 is a half, and 7 over 4. This is our gradient, so we know that tan of this angle we're interested in is equal to a half. We want to find out what that angle is, so we need to do the inverse tan. That's tan to the minus 1. Remember, you can find that on your calculator. Just above the tan button is tan to the minus 1 of a half. And now you're going to put that in your calculator and find out what you get. So we are doing arctan, or tan to the minus 1, sorry, of a half. And we're just going to work that out. So I'm just putting it in my calculator. So we get 26.5, no, sorry, round to 6 degrees. So 26.6 degrees to 3 significant figures. And really what I should have done here, I apologize, is I should have written the unrounded answer and then my rounded answer. That would have been better practice. So that's how we work. So if we know a gradient and we want to know the angle between the line and the x-axis, or the line and the horizontal, then you just need to use that inverse tan of whatever your gradient is, and that will give you your angle. So hopefully those 2 examples give you enough to get started. I'm going to give you some easier questions today, and then tomorrow we are going to work on, Tuesday we're going to work on some slightly more complicated questions using this skill that we've just learned.